Hi, chemistry students. This is your Unit 2 lesson on scientific notation review. We'll have a second lesson, part 2, on accuracy and precision, but I've decided to break it up into 2 parts. So part 1, scientific review. So first of all, we need to review scientific notation because as you can see from this chart, there are an awful lot of things that we do in science that require scientific notation. And so we need to be familiar with what it is, why it's used, and how to actually do some calculations. So in science, we deal with some very large numbers. For example, we're going to learn in a new unit coming up that 1 mole is this massively big number. We also deal with some very small numbers, like this is the mass of an electron, for example, which is a tiny, tiny number when you think about it. Now, suppose we wanted to calculate the mass of 1 mole of electrons. This would be the problem we'd have to set up. That would be no fun at all. It's a lot easier if we know the rules for scientific notation. So scientific notation is a method of representing very large or very small numbers in the form m times 10 to the nth. So m is always a number between 1 and 10, and n is always an integer, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let's look at this particular problem. How would we represent this in scientific notation? So first, you have to insert an understood decimal point. Next, you have to decide where the decimal point must end so that the number is to the left. So there's just one number to the left so that it's a number between 0 and 10. So we have to put the decimal point right there because we only have one number to the left, and that would give us a number that was less than 10 but greater than 0. Step 3, count how many places you bounce the decimal point. So the decimal point starts here, and we bounce the decimal point, if you count, to get there, 9 places. And then we rewrite it in the form of m times 10 to the nth. And m would be this number here, and the 10 would be how much we bounced the decimal point. So it would be 2.5 times 10 to the 9th. Again, the exponent is the number of places we moved the decimal point. So let's look at this one. Okay, this is a very small number. Step 2 is decide where the decimal must end so that one number is to the left. Okay, so it's going to end up here. Step 3 is to count how many places you have to bounce to get to that decimal point. So 1, 2, 3, 4, 5. Okay, so that would leave us right here. Step 4 is to rewrite it in the form of m times 10 to the nth. And yes, we have to insert that understood decimal point. Sorry, a little bit out of order. Let's do that one more time. So we insert the understood decimal point. That's going to go right here between the 5 and the 7. Then we're to decide where the decimal must end up so that one number is to the left. So we're going to count. We're going to go 1, and zeros don't count. 1, 2, 3, 4, 5. So if we're going to end with the decimal point in between the 5 and the 7, okay? And then we would rewrite it, and it would be 5.79 times 10 to the negative fifth. So that decimal point ends up having just one number to the left, so you end up with a number here that's between 0 but less than 10. The minus 5 is how many we moved it to get to this point. So the exponent is negative because the number we started with was less than 1. Now, this is really a handy tool. Multiplication rules when you add exponents. So when the number involves multiplication, you add the exponents algebraically. So for example, if you're multiplying 10 to the third times 10 to the fourth, don't have to put this in your calculator. You're just going to add these two numbers. 10 to the third times 10 to the fourth is going to be 10 to the 3 plus 4, which is 7. Here's another example. 10 to the fifth times 10 to the second times 10 to the negative third. Again, we're just going to add these up, and we would end up with 10 to the fourth. Okay, With division, you subtract, okay? So if it is 10 to the 5th, and again, it's written, so this is a slash, that means divide. So 10 to the 5th divided by 10 to the 3rd, with division, you just do a subtraction. So it would be 10 to the 5 minus 3, which will be 10 to the 2nd. 10 to the 7th divided by 10 to the 12th will be 10 to the 7 minus 12, which is 10 to the negative 5th. 10 to the 8th divided by 10 to the negative 5th is going to be 10 to the 8. Now this is a little tough. 8 to the minus negative 3, which would be 10 to the 11th. Now this one's a little bit tricky, all right? So you have to kind of do it in order. So you have 10 to the 6th. Oops, sorry about that. 10 to the 6th times 10 to the 4th divided by 10 to the 3rd times 10 to the 2nd, and you need to sort of do each together. So it's going to be 6 plus 4, and then we're going to also subtract 10 minus 10 to the 3rd and 10 to the 2nd. So we have this in parentheses because we have to do that together. This could also be in parentheses. So it's really going to be just 10 minus 5, which would be 10 to the 5th. Remember, multiplication, you're adding the exponents. Division, you are subtracting the exponents. All right, so let's try a couple of these. These are the ones you should be writing down in your notes. So we're going to have 2 times 10 to the 3rd times 4 times 10 to the 5th. And again, with the numbers in the front, we're going to just do a normal multiplication. And with the ones with the exponents, we're going to add the exponents to get the final exponent. All right? Oops. So let's look at this one first. 2 times 10 to the 3rd times 4 times 10 to the 5th. So which one of these would be correct? You could pause the video and then I'll explain the answer. But we have 2 times 4 is 8. So all of those, we can eliminate D. And that would be the M number at the front. Now we need to figure out the exponent. What do we do with 3 and 5? We don't multiply them, we add them. So that's going to be 3 plus 5 is 8. So our answer should be C. Okay? Let's try another one, the second one. 4 times 10 to the 3rd times 3 times 10 to the 12th. Okay, now this one's a little tricky. 4 times 3, the numbers in the front, the M numbers, we multiply. So you can see that that's going to be 12. Now, and you can also see that 10 to the 3rd and 10 to the 2nd add up to 10 to the 5th. So you might be tempted to pick this answer here. But why is that wrong? That is wrong because, remember, this number in the front has to be between 0 and 10, or 1 and 10, and it's not, it's 12. So what are we going to do? Well, we're going to have to move the decimal point this way. We're going to need to make this number smaller. And if we make this number smaller, we're going to have to make the exponent bigger. So if we move it so that it is 10 times less, we're going to have an exponent to 10 times more to get the same value. So that's why the answer would be C. Okay. All right. Then finally, we're going to do this division. Now, again, the front number you just do as a division. Just put it in there. 4 divided by 2, it's going to be 2. So it's going to be one of these. Then what do we do with this? Well, what's on the numerator? And then we subtract the denominator. So 5 minus 7. So it's going to be 2 times 10 to the negative 2nd, because 5 minus 7 gives you negative 2. All right? That ends this lesson. We'll do part 2 in another video. Thanks for watching.